This video will take a deeper dive with linear equations and examine some of the math behind them. We'll start by taking a look at the equation for a line in mathematical terms, y equals mx plus b. This time, we will work with data to develop an equation from a less direct point of view using another business example. Before we do that, let's take a look at some XY relationships in business. We started with our y variable dependent on x or independent. Some of the relationships include compensation and sales dollars, total cost in units produced, sales or demand in advertising, sales or demand and selling price, the stock market, and interest rates. Note that the latter two on this list are inversely related. That means as the x value increases, the y value decreases, as you can see in this display. Let's start by creating an equation that could help us estimate demand in units based on advertising dollars spent. I prefer to use the term demand versus sales because I feel it better represents consumer behavior with regards to advertising, budget, and selling price. Here's what I know in terms of data. Keep in mind that I'm using very simple data with numbers that will work out nicely for mathematical ease. I recorded 2 data points on the amount of spending in advertising and the resulting level of demand in units. Note that these numbers are fine but could also be in thousands or millions. We start by finding the slope of the line. The slope is usually referred to by the letter m. Here is the formula for the slope. You may recall this being referred to as the rise over the run, where m, the slope, is equal to y2 minus y1 over x2 minus x1. Now we plug in values for x and y. As you can see when we work through the numbers, we will result in the slope being equal to 3. This means that for every $1 increase in advertising, we should generate 3 additional units demanded. The next step is to determine the y-intercept, which is usually referred to with the letter b. We do this by taking one of our data points, such as the 100 and 500, and using our newly found slope to solve for the y-intercept, or b. We do this by plugging those numbers into the y equals mx plus b formula, and then solving or working it out for b. As you can see, b becomes 200, and now we have an equation for demand. One could look at the y-intercept of 200 as the number of people who would purchase our product with no advertising because they liked it so much. We can now estimate total demand y for any value of x advertising. Let's say that we have a budget of $120 for advertising, for example. We simply plug 120 into our new equation for demand. This will result in a demand level of 560 units, as you can see. Now, there is a huge caveat for these types of models. At some point, spending additional advertising is not going to result in additional units demanded because everyone who might be interested in your product has likely seen your ads. This is called the law of diminishing returns, as you can see on this display.